Have here is my Halloween sound generator. What I'm using is over here we have an MSP430. This is a 2553 for the hardware UART and, well, memory, and just because it's nice. That small one there is a 25AA1024 SPI EEPROM chip. Then we have an LM324, which is a quad op amp I'm using as a buffer for a voltage divider and a trigger for the LDR, which I'll get to in a bit. Next to that is we have the digital to analog converter. That's a Max 5159, which has an internal gain of 2. So for the reference I had to use a voltage divider to get VCC over 2, and it works. What we have here is a low dropout voltage regulator to give 3.3 volts. Because of those LEDs there, I needed more juice because of the voltage drop of the transistor, so I'm running off 4 batteries, 4 rechargeable, so 4.8 to 5 volts. Bit too much for the 430, so low voltage dropout regulator. Then we have those 2 resistors there of the voltage divider, VCC over 2, which goes to the op amp to buffer it, which then goes to the DAC 2 as the reference. Then we have an LDR, which is using the op amp. It's compared to this potentiometer, so I can adjust it. We have a transistor for powering those LEDs, and I'm using an FT232 breakout board just because it's faster. You can use the Launchpad's internal UART and it works, but your speed is limited to 9600. I'm using 460k, so there's quite a speed difference, which is handy for transferring files over. We have a menu from the device. So we have option 1 is erase the EEPROM, which, yeah, I might as well do now. What option 1 does is it erases the EEPROM. So I'll run that now, and it doesn't want to go. Note to self: when trying to send commands through Hyperterm, it helps if it's the active window. Okay, option 1 will erase the EEPROM, so let's do that now. You see there, those dots was just one dot while it's waiting on the write in progress to be done. Then there's a hex dump to read what's on the EEPROM, which, because I've just erased it, is all FFs. So page through it, next, previous, yada yada, usual hex dump stuff. 3 for transferring a file over. So it might get a bit shaky, I've got to swap hands. So 3 to send the file using the XMODEM. I will use the Thriller Laugh. Right, set that going. Right, and there it goes. We see down there the throughput is 3.5k a second. Sometimes it goes to 6, I'm not sure why. Probably buffering on the USB, I don't know. But as you can imagine, that's 3,500 characters a second. Using the Launchpad, we get 900 characters a second, give or take. So it's quite a speed difference. Right, the EEPROM I'm using is 128 kilobits. As you saw then, I was trying to transfer like 130 odd. So what this does is we'll abort the transfer and ignore anything over 128, which for this sound actually works quite well. So we'll do that. What it did was it tried finding peaks where we get 40 pulses for triggering the LEDs. So now we've loaded that on. If we go for option 2, read from the EEPROM, you see there's the hex dump. The first 4 bytes is the length of the sound file. The 5th byte is the peak level for playing back. And the sound actually starts at byte 512. Oh, just noticed something wrong there. It says the first 512 bytes. It's actually the first 256. There's the next 256, still FFs, and then we get to the sound data. Hex, ASCII, yada yada, usual gubbins. So exit from that, back at the menu. So display status register, that was just for debugging. At the moment it's all zeros. Set the right enable latch, again was for debugging, so that will set the latch. If I now display the status register, you see now it's 10 at the end. So play the music. It's not music, it's a sound file. See, while that's playing back, where's those LEDs? Oh, I'm not sure if they're going to show up on this. Let's see it going again. Yeah, those are UV LEDs. That's UV reactive paint on there. Plan is this is going to be outside under a tarpaulin. It's going to be quite dark at night, so we should get an interesting effect. So they actually flicker in time with the sound approximately, so it should give a good effect. Playing back. Set the playback frequency for testing. By default it goes 22 kilohertz. I'll set it to 44. As you can hear, quite a bit faster. So we'll go for 11 now. So that's the playback frequency. I'll set it back to 22. Right, trigger on sound uses the LDR to trigger when the sound goes. If pin 2.4 is tied high, it starts off in this mode, so I don't need a PC outside when I set it up in situ. So if I pick, well, first thing to do is adjust this potentiometer, turn it until the LED comes on. There's the LED on, and we back it off so it's just away from the triggering point. So now if I wave my hand in front of that sensor, let's zoom out, try and get it all in. You might not be able to see this from where you are. Yep, I can just about see that LED come on as I wave my arm in front of the sensor. So what we do is trigger on sound. Trigger on sound should be trigger on sensor, I guess, but just wording, I don't really care about that for the moment. So monitoring the LDR, send a control C. Well, if there's no PC connected, it's not going to get a control C. So if I trigger the sensor, you hear the sounds going, sends out through the serial port that it's going. Playback done. Trigger again. Those LEDs are flickering nicely. And that is my Halloween sound monitor. Chances are I'll be entering it for the 4308 project of the month. Maybe it'll get somewhere. Thank you for watching. I hope you enjoyed it.